Hello everyone, my name is Zimek and I am a technical specialist for infrastructure software. Today we will talk about Platea, which was developed here at CGS Labs. Platea is a software for roadway and reconstruction design. So let's take a look. Platea offers to users a lot of tools for designing a road, from the plan view all to the B model. It gives a lot of flexibility when designing alignments, cross sections, and it also supports the workflows. Our user interface is very intuitive and it follows basic design steps on our project. So if you are a new user, you will quickly learn how to use it. Platea allows us to quickly create a preliminary basic design, but it also has the capabilities to create a more detailed design with 3D models. Now let's take a quick look at some key functionalities in our design steps. So first we have our plan view. Here we can input points from different files, which we can use them to create our own digital terrain model. And then there are also various 3D polyline tools and reforms that we can use in our project. Then we move to our alignments. Here we have different methods for drawing horizontal alignment. We can construct main elements and sample lines in different ways. Also, there is a possibility to drape or project our alignment on different terrains, such as CGS or BricsCAD terrain, or even CGS points. After that, we can create a longitudinal profile. Here we draw interactively the vertical alignment. We can calculate the input super elevations. All of these are then checked with our national standards that we support in Platea. So if something is not correct, for the type of the road that it shows, it will give you a warning and let you know. We then move to our cross sections. So here we draw the elements such as upper layers of the road, the embankments, the drainages, and all other things. We can get the quantity takeoff or the volumes, and we can use this information to create a 3D model. So 3D model is created with 3D solids or all the user-defined materials and cross sections. And this model can be used to create a B model. So we attach it with property sets, with properties. So for that, we use functionalities such as property manager and property set editor, where we define our tables and assign them to our 3D solids. Then we have also an option to export it to IFC. And then let's check the areas of application. So what are the areas of application for Platea? Well, Platea is mostly used for designing highways, local and urban roads. Also, we have tools for creating intersections and roundabouts. But it can be used for various projects for overpasses, bypasses, and even some site design with the amount of tools that we have in Platea. So now we will move on to my technical demonstration, where we will check these steps. So now we will start with the technical demonstration. So here we have a BricsCAD with CGS Labs installed. If we move to our CGS Labs ribbon, you can see all the products that we have. And when we click Platea, it will also open up other ribbon tabs such as layout, profile, and cross sections. These are our bigger design steps, so we will go over them. First of all, we will start with the layout. We will define a new alignment. So we give it a custom name, for example, an axis, and we give it a starting stage. Then we can define the category of the road. So for this example, we will use connecting roads, main road, original road, and some design speed which we can change. Then we move to our plan view. We will input some points from a file. So we will use some points that were recorded by a surveyor, and we will use that as base. So we have an X, Y, and Z coordinate, and also some other information. Some additional attributes which we will import into a drawing. If we zoom in, we will see the elevation of a point and its name, but we can also show other information such as what kind of a point it is, so which cross section, and if you look now, we will see the right edge, left edge, and axis, and which point corresponds to which sample line. So we have this information prepared, and we can use it for our alignment and sample lines. So based on this point, we can create an alignment. We have different methods here. We can draw a tangent polygon, stick method, or we can use some kind of conversion. For this example, we will use the best fit method. So we will create best fit alignment, and we will choose these points with the point attribute axis. I will select the alignment direction and select which alignment I want to create. This will calculate in a few seconds the best approximation for the main elements. So now we have a window for the lanes and widenings. We will just click OK for now. Then we also have a window or some kind of warning that says that horizontal elements don't match the selected standard. So we need to check that. And also we get a report for the best fit analysis, so we can see which points offset are the most offsetted from the alignment. Now that we have the whole horizontal alignment, we can edit it. So we have these tools for edit alignment tangent polygon. We can select a vertex and just change the radius for this curve, and maybe change where the spiral starts, or any other parameters that we want. It will again draw the lanes, and we can change this for the full axis. So in this way, we quickly got the whole alignment without drawing every main element by itself. Now we can also create sample lines. So sample lines can be created through these points. And for that, we will use create sample lines from points. And this will collect the data from the layer, and we can choose which method we will use. We select the width, so for the left and the right side, and we will get the sample lines for the full alignment with the names and with the station included. So the next part is projecting or draping the alignment to a surface or points in this case. So we use the next command, drape, where we can select the surface or points which will be used as elevation data. So let's click OK. We get these green lines, and if we look in the 3D view, we can see that the full alignment and the sample lines were projected on these elevations. So we also have an options to create a DTM or digital terrain model within CGS. We can use points or break lines, but we can also use BricsCAD surface. So for that example, we can maybe create a new axis. This will be our new road, for example. And I will just quickly draw tangent polygon in this location. So this new road can be now draped to a surface. I have a surface here, so I have a BricsCAD surface prepared with some triangle to match. So I can use that from another drawing. So let's go back to drape command, and I will add another external surface. I will choose the DVG that is used for that, and it finds me the surface, the BricsCAD surface. So now if I drape it, I can see that the elevation data has been found and the alignment has been projected. So now we can move on to our profile. But first, we can also create those lanes that were set, that were predefined, but we want to have them go over the left and right edge. So for that, we will just quickly delete those lanes, and we will create new ones over these points. First of all, I will search for all the points that have the right edge attribute. As we can see, it finds all the points. I will just select the first one and the last one, and I will put it to selection. Then I will go to our site design ribbon tab and select the command polyline from points. This will quickly create me a 3D line from the points with the right edge attribute, and I will also do this for the left edge. Let's create another line. And in a few seconds, I have these lines prepared. I will also need to have 2D polylines. So for the road lanes, I will just use ones I already prepared beforehand. So now let's move on to our profile view. We will click the profile ribbon tab. We will select the correct axis and use the draw profile view command. So now we select the scale that we want to use. We can choose the section of the surface and the starting and ending stage. We select OK and just click a point where it will be drawn. So now we have the surface or the elevation of the existing road and all other information such as horizontal elements, roadway widths, and all other from the plan view. So now we will use these existing cross sections that we have to define our existing super elevations. So I will use this draw existing super elevation command and just use the file that I have already prepared and get these lines in this rubric. I can change them to our active super elevations. So I will just do that quickly. Or I can define new ones with the calculate command and use the edit super elevations where I can change them manually. So now I can also calculate the new profile. So if I want to raise the existing road, if I want to move it up or down, or if I want to change the width or the thickness of the courses for wearing course or base course, or I can just lower everything, for example, like this, 10 centimeters down. I also get all the volumes here calculated, and I can also draw the reconstruction points. So these reconstruction points will be used for our new alignment, for our vertical alignment. For that, we can use the path speed command as we did in the layout, but this is only for the vertical profile. So I will use the reconstruction points and click OK. So now we get a report for the past week, and we can also see all the curves, the curvature, and we can change that as we like. So we can change the profile, edit the profile, and set other parameters as we want. We can change this for the tangents or the curves. So for example, like this, we can change this radius to something else. So now we can move on to our cross sections. Let's click the cross sections ribbon tab, and I will use the draw cross sections view. I will just select the current drawing, or we can use some other drawings to draw the cross sections. We can change all these settings as we wish. So I will just change this elevation, and I will select some point in the drawing. This will draw all the 114 cross sections that we have in our plan view. And let's take a look. And we also get the road height and the super elevations. So we can use that to draw other elements. So we can make some pavement elements. For example, the first surface layer, I will use the surface course material, or I can make our own and define the thickness of the layer. I will choose under which length I want to draw this, and this will draw me all the surface layers on all the cross sections. For this case, we can also use macro, so I will use that on the first 3 cross sections, and I will draw it again. In this macro, I already defined all the materials and the elements that I want to have. So I want to draw it by hand. So here are the first 3 cross sections, and I can make a quantity takeoff. So I will do that for each cross sections, and also the sum for all 3 cross sections. So I get these informations for all the materials, and I also get the sum or the volumes for each of those. Now that I draw the elements, I can make a 3D model of it. So I will move to our utility tab, and I will use the draw 3D model command. I have all the materials that I used, and I can also select a property field, which will be automatically filled with information that we have. So I will use the surface course, and surface, and maybe some CGS property. that for the base class. I will click OK. I will wait a few seconds so that solids are created, and I will just check it in the 3D view to see how it was created. I will change the visual style to a realistic or the shaded, and I can see all the solids that were created. Well, I can now also define some new property sets or change them, or I can use the property set editor command and select the surface layer, and I can see the property group that was assigned to this solid. I can now export this to IFC, and it will give me an IFC with all the necessary information. At this point, I would like to invite you to try out our free trial. So we offer a 14-day free trial without any functional limitations. You can request a test license on our product page. And if you need any additional information or you have questions, you can let us know by email. This will be everything from my part, and I would just like to thank you for your attention.
Have you ever seen wind turbines being transported? Probably not, as the transport usually takes place late at night when there is no traffic on the roads. Transport from the factory to the installation site presents a big challenge because the rotor blades are molded in one piece that can be longer than 80 meters. To make sure that these parts are delivered successfully, sweat bed analysis must be made along the route. These analyses are very complex and require a lot of time. However, in AutoCAD software you can make such assessments quickly and easily with a few clicks. My name is Petra Tihola, and I'm going to show you some interesting features found in the AutoCAD software. AutoCAD is a professional software solution for vehicle sweat bed analysis used by civil engineers, transportation professionals, architects, and urban planners. AutoCAD enables the simulation and analysis of vehicles' maneuvers, 3D vehicle animations, and more. In addition to the previously mentioned wind turbines, transportability analysis can be performed on practically all possible vehicles, from cars to airplanes. Civil engineers use it for verifying the usability of all types of road design projects, including roads, intersections, roundabouts, underpasses, overpasses, and similar places. AutoCAD also provides easy-to-use tools for architects and urban planners. They can perform simple vehicle maneuvers, carry out turning simulations, and identify potential limitations in the design of garages, parking spaces, and intervention routes. Moreover, AutoCAD is a proven useful tool in the process of factory design. Using it, engineers can simulate the transportation of goods on the factory lanes, as well as simulate automated guided vehicles for the transportation of goods on factory grounds. Finally, AutoCAD also enables simulation of aircraft maneuvers to support the design of airport infrastructure. The biggest advantage of the software is that it includes a huge library of country-specific reference vehicle libraries defined by national guidelines and an extended collection of real vehicles covering aircrafts, buses, trucks, trailers for wind turbine transport, cranes, emergency vehicles, and more. In addition, AutoCAD also provides an extended vehicle customization option, enabling users to customize available vehicles in the libraries provided or create completely new vehicles. By scanning this QR code, you can find a list of all vehicles. For each vehicle, you can find the horizontal and vertical analysis feature to simulate the vehicle maneuvers and check transportability. You can compare one vehicle's path with another vehicle or with different built objects to create a comparison report. But that's not all AutoPad can do. In the latest release, our development has proven once again that they know how to think out of the box, and they took AutoPad development to the next level. We introduced the 3D vehicle modeling creation option and 3D vehicle animation feature. You can now create a 3D animation based on any horizontal swept path analysis, and all 3D models are created automatically, even if the vehicle has custom-defined values. The fact that the user does not have to create a 3D vehicle model by hand gives AutoPad a great competitive advantage over other similar programs. Now we will move to the software, where, based on an example, you will be able to see for yourself that creating a swept path analysis is really fast, simple, and effective. Click on the vehicle library and select one random truck. Then you can click on this button to edit this vehicle. Enter the new name and press OK. You can now change the parameters on the right and add another trailer by clicking this plus button on the left. Then you also have some additional settings to customize your vehicle. When you have defined all the parameters, just confirm by clicking OK. Now you can first make a horizontal analysis of this vehicle. This can be done in two ways. The first option is to run the Easy Drive command, and another option is to run the horizontal analysis and then select the polyline that represents the vehicle route and press Enter. Once you have the swept path analysis, you can start the animation. Click on the animation icon, select the existing swept path and click Play. You can now see the animation of the vehicle. Based on this analysis, you can also check offsets, collisions, and generate different reports such as steering angle and vehicle profile. These reports are dynamic and update automatically while editing the path. Before we move on the 3D animation, I will show you another trick that will make your job a lot easier if you need to create an analysis for different types of vehicles. This new feature, called Swept Path to Polyline, creates a new polyline along the existing swept path. You can then select a new vehicle and perform analysis on the same path. Now let's take a look at the most interesting new feature of the AutoPad software. This is a 3D animation and related 3D vehicle modeling creation option. Run the 3D animation command and select an existing path. Then you press the play button and the vehicle starts moving along the path. Finally, you can also create a 3D model of the vehicle anywhere along the path. To sum up, AutoPad is an excellent software with many powerful tools for creating horizontal and vertical swept path analysis. In addition to the features shown in today's presentation, it has several other functionalities that you can try at any time. Download the free trial version of AutoPad, test it, and see how easy and quickly you can learn to use it. you can request a test license via the product page on our website. To keep up to date with our latest blog posts, webinars, tutorials, and success stories of our customers, follow us on LinkedIn. Thank you for your attention and feel free to contact us if you are curious about the big picture to get a better idea of what AutoPad is all about. Are you one of those people who are spending hours and hours of your precious time modeling road traffic signaling? If your answer is yes, then you are in the right place. My name is Petra Tihole and I am very excited to take the next 10 minutes to show you some powerful tools to speed up and simplify the process of designing 3D traffic signs, road markings and gantries using AutoSign. AutoSign is a professional software solution for planning traffic, signs, and road markings in both urban and inter-urban road infrastructure, redesigning the traffic flow, or implementing new practical solutions to any problem that traffic engineers may face. It also provides tools to design details of parking facilities, such as delimitation lines, vertical signaling, high control gantries, and more. Besides, it is also used for warehouse, traffic design and management, cycle path network design, ski resorts, sports center design, and safety driving center design. The advantage of using AutoSign is that it includes extensive collections of country-specific traffic sign libraries, road markings, traffic lines, and other street furniture elements. Users also have the advanced option to include their own traffic sign blocks into a customized library in AutoSign and employ them in designs with the same features that the predefined libraries possess. The biggest competitive advantage over other similar programs is definitely the creation of a 3D model. It only takes one extra click to create a 3D model of traffic signs, road markings, and gantries based on a 2D. Besides, AutoSign also has tools for attaching attributes and IFC export and import, which allows you to collaborate with other experts on demanding BIM projects. In today's demonstration, we are focusing on the traffic signs with editable text. These traffic signs are included in AutoSign libraries and can be easily recognized by the suffix stamp in their names. At the beginning, run the Library Manager command, click on the Download Libraries, and install any library. Then check the box at this library and press OK. After that, run the traffic sign command. A new dialog box opens where you define the alignment at the top. After that, you select the group and check the box at the new design if you are planning a new traffic sign. Then click on the Settings button to define parameters for post and foundation. First, define the parameters for the post. Then check the box at the Draw Foundation option and set new values. After that, confirm by clicking the OK button. Select the traffic sign and define its position in the layout. Once the position is defined, the traffic sign editor enables you to customize the text, edit the content and the properties, and define the text position within the sign. In this step, you can also modify colors or any other aspect of the sign if needed. When you have finished, click on the Save block to insert the customized sign into the layout. At this point, AutoSign takes you back to the layout, where the 2D traffic sign already includes all the changes. We can already create a 3D model of this traffic sign at this point But I will now show you another trick, namely how to add design to the gantry. Run the gantry command, select the alignment and define the frame and foundation. When you have defined all the parameters, confirm them by clicking the OK button. Then specify the gantry position and then the scheme position. After that, click the Edit command, select the traffic sign and check the scale. Next, run the Edit command again, but this time choose the gantry. Click on the Settings button and define the scale factor for the scheme. Then click on the icon below and select the sign you want to add to the gantry. After that, you specify the guide sign position on the gantry. Here, be careful to show the place on the scheme of the gantry. A dialog box opens once again, where you click OK. If you have a surface in the drawing, you can now draw a 3D model. Click on the Draw 3D Sign and Markings icon, select the surface and press OK. As you can see, a 3D model of the gantry is automatically created with the added sign. This was just one example of how AutoSign software can speed up traffic signal design. At this point, I would kindly invite you to download the trial version via the internet page and try these powerful functionalities on your own. On our website, you can also find many tutorials that will help you with your learning, but you can also contact us at any time and we will be happy to assist you. Make sure to check out on breakout sessions of our other CGS Labs software solutions. Thank you for joining me and I hope you enjoyed it.
Hello, I'm Petar Dragic, team leader at the PowerPad, and it's my big pleasure to present you PowerPad, Powerline Design Software. Let's first share with you agenda of this presentation. At the beginning, I wanted to make a short introduction about the solution. Then I will go in live demonstration of the PowerPad to present you the main features of the PowerPad and how you can to create Powerline project. At the end of this presentation, I will tell you how you can to send a request for 30 days free trial. Let's first answer the question why we create this solution. Answer we can to find on this chart. Actually, one of the biggest problems in the life cycle of the power lines is restriction in sharing information. And actually, with the PowerPad, we moving forward from traditional or classic approach to BIM approach in the life cycle of the power lines. PowerPad brings a unique format for sharing project information from the first to the last phase of the life cycle of the object. We know that there are different requirements for different markets, and that is the reason why we create solutions to support 2D design and 3D design of the power lines with the possibility for creating different analyses and calculations of power lines. Actually, our 3D design is 3D BIM design, and that record is very important because with that record, we don't have any limitation in sharing information in next phases of the power lines. Here are some examples, and if you want to check, just scan QR code. Another very important question is where we can apply PowerPad. PowerPad can be applied for any power lines, and it means for transmission and for distribution lines. Let's go now directly in software solution on live demonstration to present you PowerPad software solution for power line design. This is how it looks when you start with the PowerPad solution. On homepage you can start with new drawing, or you can to reopen recently used files. PowerPad is created on BSB, BricsCAD Solution Build Technology. And it means with this solution you can to create power line projects and also any other technical drawings or 3D or 3D BIM models. In this example, I have the points with XYZ coordinate. And if you're going on properties, you can to see that is the point with XYZ coordinate. With these points, I want to create surface because I want to create new power line. I will go on the commands for surface and create surface from points. In properties, I can to see all parameters of my surface. I can to change visibility of my surface. And of course, I can to set which view I want to have. Let's go on top view and start with new alignment. PowerPad support to create new power line and to redesign existing power line. I will go to create new power line. Here I need to define the name of the power line. Let's define overhead line, station, support name, and what is very important, I need to define tension support model. I will use default value for tension support model. Of course, I want to drop it on the existing surface. Now I need to define the position of my poles. And like you can to see, it is very simple. Just like defining polyline, you need to define the position of your poles. When you finish, you need just to agree with the enter or right click. If I zoom, you can to see that each pole is labeled. And of course, each of the pole or the alignment, I can to move like any other vertex of the power lines. One of the biggest advantages of this solution is solution automatically created 3D elements based on 2D design. And if I zoom, you can to see that I have my poles in 3D. Let's go back on 2D view. For better visibility, I will turn off properties, and if I go in here on Project Explorer, I can to see all elements of my created alignment. Of course, for surface too. Next step in defining power line project is to define another elements. I will go on one of the poles and I will go now to add insulator. I need to select pole and I need to define on which attachment point I want to add insulator. Here I can to define insulator just on this pole or on the all poles. I will define it just on this pole. And now you can see that I add insulator on the pole. If I want to add insulators on all poles, I will go here, just select one pole and define the insulators for each attachment point and apply it for all poles of the same data model. Just press OK. And now you can to see that I have added insulator on my poles. In next step, I need to define conductors. Let's command for adding conductors, define on which alignment I want. Here I need to define the name and I need to select which conductor I want to add on my phase 1. I will add from first to last support with default weather and referent condition. Press OK, and now you can see that I have added my conductors. Let's add conductors on another insulators. Repeat the command once again, and now I have 3 phases on my alignment. If I rotate it, I can see the real position of the conductors. Here you can see the influence of the wind, actually weather conditions. If I want to create a profile view, I need just to go on profile, on the command for profile view. Here I can define another parameters. For example, if I want to have offset of the terrain, left and right. Of course, here are some other labelings. For example, if I want to have that information on the profile, and I need to define where I want to put my profile. On profile, you can see the main information about the station, terrain elevation, span, and etc. And of course, graphical preview of our alignment from layout. Here are also labeled the lowest point and the maximum sag of the catenary. Okay, now I have defined alignment and my profile view. Of course, if I want, I can add another pose with the commands from support. I can also edit insulators, or I can remove or edit new conductors. Let's go on the next group of the commands from this solution. I can make different reports based on my created power line. For example, if I want to report sag tension of this alignment, I need to define from which alignment I want to have created the sag tension report and for which conductors. I will choose all conductors, and of course I can here define the temperature range and step. I will use the Excel format for my report for sag tension report. Let's press OK. Define the name, define sag tension report, and press OK. Now you will see that I have automatically created sag tension report based on my alignment, which I used for alignment overhead line. Here are the most important data for sags and for tensions. Of course, PowerPad supporting another reports like load reports or quantity report or creating coordination reports, and of course solution supporting to add different weather and referent conditions, because there are not the same the referent and weather conditions on each market. If you want to use another data models, of course in solution you can see that you have predefined data models, but if you want to use another data models, it is also possible to add another poles, for example, insulators, or to add another conductors. Let's for the end export this data model in IFC format. I will go on IFC export. I want to export my overhead line, and I will use IFC 2.3. Just press OK and define the name. And just wait a few seconds to create that IFC record. When IFC is recorded, it will be automatically opened in solution for previewing your IFC format. Let's see how it looks. If I zoom, I can to see that is exported all elements, surface, and elements of the power lines. When I click on each of the element of the power line, I can to see property set of that element with the main attributes. For example, if I also click on catenary, I can to see the conductors with attributes. Let's go back on my slides. Let's go back on my slides. It was a quick demonstration of the PowerPad solution. For more information, please visit our product web page. Just go on your internet browser, type power-pad.com, and you will get product page of the PowerPad. On that page, you can find request form for sending requests for 30 days free trial. Also, you can find another interesting topics. For example, you can find our blog page where you can read our weekly blog posts. You can find a learning page for learning how to start to use software solution. If you have any questions, feel free to contact us. Thank you for your attention. It was my pleasure to present you PowerPad. Stay well and goodbye.